Lesson 5.2, page 198 in your hardcover book. The goal for today is to be able to make and use ratio tables. And your essential question from yesterday was, how can you find two ratios that describe the same relationship? Also, I remind you to read over the targets that you have to meet for lesson 5.2 in your direction packet. All right, you can take a look at page 198 or up on the screen. It says two ratios that describe the same relationship are called equivalent ratios. You can find equivalent ratios by adding or subtracting quantities in equivalent ratios and multiplying or dividing each quantity in a ratio by the same number. You can find and organize equivalent ratios in a ratio table. Okay, just for a warm-up, I have a problem written in here. I would like you to read it, fill out the ratio table, work without your partner, and then when you're done, compare the answers that you get with your partner, talk about the strategies that each of you use to figure it out, and then check back in for the correct answers. All right, you should have talked about how you got the answers, and these are the correct answers you should have gotten. Okay? Now, some of you may have done it the same way, and that's perfectly fine. Others that have partners may have done it two different ways, and if both of you came up with these answers in your own way, that's perfectly fine. Okay, let's move on to example 1. Completing the ratio tables. It says find the missing values in each ratio table, then write the equivalent ratios. So you've got pens to pencils. You start out with 1 pen per 3 pencils. Now, below that in A, it says you can use repeated addition with the original ratio to find the missing values. And keep in mind, you are trying to find missing values. There are empty boxes. So if you add 1 to the pens and 3 to the pencils, you will get the matching ratios. Notice, what you do to the top, you don't have to do to the bottom if the pattern is different. So the equivalent ratios are 1 to 3, 2 to 6, and 3 to 9. In B, here you have dogs to cats. You also can use multiplication to find the missing values. In this case, they did 4 times 2 is 8. 8 times 3 is 24. Multiplication. Cats, they did times 2 and times 3. Now, when you're doing multiplication and division, the ratios are going to have to match. I'm sorry, the ratios don't match. The operation, what you do, the top and the bottom, do need to match. So your equivalent ratios are 4 to 6, 8 to 12, and 24 to 36. I do have some practice problems that I'd like you to do. There in the box, it says find the missing values in each ratio table and write the equivalent ratios. Now notice it says find the missing values first, then do the ratios. So if you will go ahead and do that and come back when you're done. This needs to be done in your notebook. It needs to be written out completely under 5.2. Okay, here are the answers. Notice 4 and 15 are the numbers they want you to insert, and then they have a semicolon and give you the ratios. Here are the numbers you insert and then the ratios. So check to see if you did that right. And in the meantime, here's a video.
Find the missing values in the ratio table. Then write the equivalent ratios. Part A. You can use repeated addition with the original ratio to find the missing values. 2 plus 2 is equal to 4. 5 plus 5 is equal to 10. 4 plus 2 is equal to 6. And 10 plus 5 is equal to 15. So, the equivalent ratios are 2 to 5, 4 to 10, and 6 to 15. Part B. You can use multiplication to find the missing values. 3 times 3 is equal to 9. 4 times 3 is equal to 12. 12 times 4 is equal to 48. And 9 times 4 is equal to 36. So, the equivalent ratios are 3 to 4, 9 to 12, and 36 to 48.
All right, and the next thing I need you to do is the on your own on page 198 and check the answers in the answer book and come on back. Example 2 on page 199. You are making sugar water for your hummingbird feeder. A website indicates to use 4 parts of water for every 1 part of sugar. You use 20 cups of water. How much sugar do you need? You can solve this problem by using equivalent ratios. The ratio of water to sugar is 4 parts to 1 part, and it tells you that right in the problem. So for every 4 cups of water, you need 1 cup of sugar. Find an equivalent ratio with 20 parts water. So let's look at method 1. You can think of making a larger batch of sugar water as combining several batches of 4 to 1 mixtures. Use addition to obtain 20 in the water column. So let's look at our ratio table. Top line, water in cups. We know that we're going to start with 4 parts water. So 4 cups of water. Then sugar, it told us in your problem, if you had 4 cups of water, you had 1 cup of sugar. The only other thing we can fill out is the tan part right here, because the problem told us we were going to have 20 parts of water. The rest we have to figure out. So we're going to do addition plus flour plus 4 plus 4 plus 4 equals 20. That comes out evenly. And because it's only 1 cup of sugar, we know we're only going to add 1 cup of sugar to every 4, and your 4 is right here too. Then so we might as well go 1 to 5. So the ratio to 5 is equivalent, the ratio 20 to 5 is equivalent to 4 to 1. So this and this pretty much mean the same thing. Again, very much like a fraction. In method 2, you can use a ratio table and multiplication. You multiplied the amount of water in the recipe by 5 because 20 divided by 4, and remember, you already know the 20. 20 divided by 4 is 5. So you need to multiply the amount of sugar by 5. Multiply each part of the ratio in the original recipe by 5. Again, multiplication, same, same. Here, different can be different. Multiplication and division, the same. That told you that back in the keynotes. Now the ratio 20 to 5 is equivalent to 4 to 1. What I would like you to do right now is to open your spiral, of course, and under section 5.2, I want you to draw a table just like this, same labels. I want you to start with 4 and 1 and put 20 up here. So go ahead and do that, and I'm going to have you do something different with this chart. Do not fill in these white boxes with numbers. Just draw the chart, filling in 4, 1, and 20, and come back when you're done. Okay, my challenge for you is to fill out this chart again, but this time I want you to do a mixed approach. A mixed approach, let me just make sure we had it on this one. Yep, I want you to go with a mixed approach. So you might have two multiplications. You might have a multiplication and an addition. You can mix these numbers up. That's what I would like you to do. Find a way that you use two different operations for each one. I'll give you a hint. The two operations are multiplication and addition and multiplication and addition. Up here and down here. Not necessarily, no, I'm not going to even say that. Multiplication and addition are your problems, or are your operations. See what you can do. Come back when you're done. Okay, one of the ways you could have done it is 4, this 4 right here, 4 times 4 would be 16, plus 4 would be 20. Here you would have 1 times 4, because you were already doing times up here, times 4, and then you would do plus 1 and get 5. So that is another approach you can take. If you did it a different way, check with me to see if it's right, but that would be one that you could use that I just gave you. All right, let's take a look at this. You are making a juice drink. The directions on the can of juice concentrate indicate to use 6 parts of water for every 1 part of juice concentrate. You can use 24 cups of water. How much juice concentrate do you need? Again, in your spiral, draw the chart and come back for the answer. The answer, 4 cups.
You are making a juice drink. The directions on the can of juice concentrate indicate to use 6 parts of water for every 1 part of juice concentrate. You use 24 cups of water. How much juice concentrate do you need? You can solve this problem by using equivalent ratios. The ratio of water to juice concentrate is 6 parts to 1 part. So for every 6 cups of water, you need 1 cup of juice concentrate. Find an equivalent ratio with 24 parts water. One method you can use is to use a ratio table in addition. You can think of making a larger batch of juice drink as combining several batches of 6 to 1 mixtures. Use addition to obtain 24 in the water column. 6 plus 6 is equal to 12. 1 plus 1 is equal to 2. 12 plus 6 is equal to 18. 2 plus 1 is equal to 3. 18 plus 6 is equal to 24. And 3 plus 1 is equal to 4. The ratio 24 to 4 is equivalent to 6 to 1. So, you need 4 cups of juice concentrate. Another method you can use is to use a ratio table in multiplication. You multiply the water in the recipe by 4, because 24 divided by 6 is equal to 4. So, you need to multiply the amount of juice concentrate by 4. Multiply each part of the ratio in the original recipe by 4. 6 times 4 is equal to 24. 1 times 4 is equal to 4. Again, the ratio 24 to 4 is equivalent to 6 to 1. And you arrive at the same conclusion that you need 4 cups of juice concentrate.
Okay, at this point, I need you to do the on your own and check back with me for the answer.